Okay, so this is part 2 of the lesson on 6.5. We just got done factoring a bunch of polynomials, and now what we want to do is talk about the graphs. So I decided to change the examples to make them a little bit easier, and we're going to use the graphing calculator. So we're looking ahead. We're basically going to be doing these graphs in the next 2 lessons as well. So we will need to understand the characteristics of the graph of a polynomial. For our studies, we are really examining trinomials of degree 2. We call this category of polynomials a quadratic. Use the graphing technology, so TI calculator, or you could also use Desmos. That would be a good site. If you don't have a graphing calculator, go to desmos.com and you can type in the equations and graph them. Now, we're going to use a calculator to create a table and to graph each of the following functions. And then we'll want to look and see, what do we notice? What if we factored the polynomial? So here's an interesting idea. If you were to factor this, does anybody know what the two factors are? Yes, -4, +2, okay? And so that's going to come up in terms of the graph. So let's go to our y equals. I've actually already programmed it in there. You can pick any line to graph that, and you can see the shape of the graph by pushing graph. We call the shape of a quadratic a parabola. So that's the shape of a parabola. It has an infinite number of points, but it's really hard to transfer that graph very accurately onto this graph without a table. So we're going to use the table. In order to get to the table, we go second graph, and that takes us to a table of values. So let's just draw out the table, and it'll make it easier to plot. So let's start with -3, 7. So these are our x and y values. By the way, if you just created a table of values, -2, -1, 0, 1, 2, 3, if you were to plug in those x values into your function, you would get the same y values that are in the table. Okay, so I'm looking at my table. I'm just going to put it off to the side, -2, 0, -1, -5, 0, -8, 1, -9, 2, -8, and 3, -5. So first, just looking at the table, is there anything you notice at all? Well, let's go ahead and plot the points, okay? So we're going to go, did I do the right one, by the way? Yes, I did. Okay, graph, table. All right, so let's plot the points. -3, 7. -3, 7 is here. So remember, go x, y. -2, 0. -1, -5. 0, -8. 1, -9. 2, -8. 3, -5. Can anyone tell me what the next point, are you seeing that there's symmetry happening here? So if I connect these points, it's going to draw a parabola. Any idea what 4 is going to be? Without looking at the table, can you see the symmetry happening? And 0, so 4, 0. And then what about 5? Looking at the pattern, it's going to be 7, 5, 7. Okay, because a parabola has symmetry. It has an axis of symmetry, which is this line right here. Well, this is not, it's not a straight line. It's a dotted line because it's the axis of symmetry. It's not part of the graph. Axis of symmetry. Okay, and does anybody remember what the equation of a vertical line is? This is going to be x equals 1 is the axis of symmetry. Now this point right here where the parabola comes down, it decreases, and then it changes directions, we call this minimum point the vertex. Okay? Notice here are, what are those points that I just circled called? They're on the x-axis. They're called the x-intercepts. Y-intercept happens on the y-axis. So the y-intercept would be 0, 8. This would be my y-intercept. Here, negative 2, 0 and 4, 0 are what we call the x-intercepts. Why? Because they lie on the x-axis. Notice that the factors are x plus 2, x minus 4. Our intercepts are negative 2, 0 and 4, 0. Is there any reasoning behind that? Is there any relationship there? Well, before, in the last section, we were talking about how, here's my equations written again here, okay? I'm just going to actually, here, I'll do this. There we go. So we said the factors are x minus 4, x plus 2. Remember when we talked about setting it equal to 0? If we set it equal to 0, that means y is equal to 0. That's how we're finding the x-intercepts. X minus 4 equals 0. X plus 2 equals 0. Plus 4, x equals 4. Minus 2, x equals negative 2. So these numbers right here, when we set y equal to 0 and we solve for x, we just found 4, 0 and negative 2, 0. Those 2 points are our x-intercepts. So the factoring helps us find the solutions x when y equals 0. In other words, when we solve, we find the x-intercepts. Now let's look at this problem right here and notice how is this problem different than the previous problem yeah, well, this one is positive, this one starts with a negative, okay? Right, and then you see that those signs are opposite. So now let's go to our graphing calculator, go to y equals, I'm going to insert a negative in front of the x squared, and I'm going to change this to positive, positive. So all the signs are now opposite, okay? And what's really interesting to notice is the x squared has a negative in front of it, okay? Let's graph it. Okay, so now we have a parabola. This is very similar to the throwing the ball question, right? We threw a ball off of a cliff and it went up and then it came back down. It landed on the ground. The x-intercepts are going to be the ground here. So this equation is actually exactly the same as the other equation except for the signs, and so the parabola is opening downward. What do you think about this equation makes the parabola open downward? What do you think about this equation makes the parabola open upward? Any ideas? Yes, the positive in front of the x squared means the parabola will open upward. The negative in front of the x squared means the parabola will open downward. Okay, let's do our similar table of values. So we're going to do x and y, even though this says g of x, the same thing, okay? So we go to the second table, and we're going to grab some values here. So let's start with negative 3, negative 7, negative 2, 0, negative 1, 5, 0, 8, 1, 9, 2, 8. So again, you're starting to see that symmetry happen around the vertex. The vertex is where we start to change directions, and you notice there's 8 and 8. So 3 is going to have the next number, 5. 4 is going to have the same as negative 2, 0. 5 is going to have the same as 3 because you see that symmetry going there, negative 7. So now if we plot the points, okay, here's our y-intercept, 0, 8. Goes on the y-axis. 1, 9. Go over 1, up 9, right? And then you start to see the symmetry happening. 2, 8. Okay? That's my, wait, yeah, 2, 8, and then 3, 5. So over 3 up to 5. Over here, that's negative 1, 5. That's its symmetrical point here and here. And then you have your intercepts, x-intercepts. There's an x-intercept, there's an x-intercept. How do I know those are x-intercepts? Because they have the y value is 0. So we have negative 2, 0, 4, 0. Notice that they're exactly equidistant from the axis of symmetry. They're both 3 units from the axis of symmetry, which is still x equals 1. And then 5, negative 7 is here, 5, negative 7, and what's the other one? Oh, negative 3, negative 7, negative 3, negative 7 is over here. So you have a parabola that opens downward, and essentially it opens downward because of that negative sign in front. But again, if you were to look at the problem and if you were to factor it, what's the very first thing you would do if you were going to try and factor something like this? Yes, you would factor out the negative 1. X squared minus 2x minus 8. Oh, that's exactly the same problem. Negative 1, x minus 4, x plus 2. You still have x and y intercepts of 4, 0 and negative 2, 0. Still the same exact x-intercepts. It's just that because of that negative sign in front, the parabola opens downward. So the factors, from the factors, we can get the x-intercepts. Where do you see the y-intercept in the equation? Yes, if you set x equal to 0, x is 0, the only thing left is 8. That's our y-intercept. So we have y-intercept and we have x-intercepts. Okay, so that's just a little bit of a preview of graphing a parabola. There's more patterns here that we could talk about too in terms of squares, perfect squares, and such, but essentially I just wanted you to know how to use your graphing calculator or Desmos.com, and then some of these critical points, also noticing what the general shape is of that parabola and the symmetry.